Hello and welcome. You are listening to AI with Shaily, your go to source for the latest and greatest in artificial intelligence and cutting edge tech innovations. I'm your host, Shailendra Kumar, here to unpack some exciting developments shaking up the world of near infrared photon detection and object recognition, a niche but hugely impactful space in AI sensing technologies. So picture this: you're out hiking on a foggy morning, your smart wearable needs to recognize distant objects accurately, even in poor visibility. Traditional infrared detectors have been power hungry, bulky, or just not sensitive enough for a seamless experience. That's why the recent breakthrough from OLEDWorks and their research partners, announced just this past November, feels like a game changer. They've developed a hybrid organic on silicon upconversion device that converts near infrared light. We're talking wavelengths around 1.1 micrometers, possibly stretching to 1.7, into visible light with an astonishing photon to photon gain of up to 900%. And they do this at incredibly low power levels, below 1 microwatt per square centimeter. Why does this matter? Well, this means sensors can now be super sensitive, compact, and low power, paving the way for high resolution imaging arrays that can be pixelated and scaled without burning through your device's battery. It's tackling the old problem of energy inefficiency in NIR detection that's long plagued this field. For me, this tech reminds me of when I first programmed my early computer vision systems. Back then, we could only dream of sensors this efficient and tiny. Now, such devices could become as common in everyday consumer electronics as our smartphone cameras. Around the same time, there's buzz on social media about new materials stepping up the infrared sensing game. Researchers are harnessing quantum dots, graphene, and two-dimensional semiconductors to create detectors that not only boost sensitivity but work without needing bulky cooling systems. A big win for medical and environmental monitoring, where rugged all-weather capability is crucial. There's even fascinating work with gold quantum rods paired with organic molecules that achieve molecular scale NIR to visible photon upconversion, opening new avenues in photochemistry and ultra-stable sensing. And if wearable or environmental technology is your jam, keep an eye on polariton-based infrared photodiodes. These are lightweight, low-power sensors that could one day embed directly into fabrics or gadgets, delivering smart recognition on the fly. What's the big picture here? We're moving toward a future where AI-driven devices have sensory neurons inspired by volatile memory stores or hybrid photonic tech, giving us robust object recognition in all conditions without draining power reserves. Ideal for everything from autonomous drones navigating smoke filled skies to your smartphone unlocking securely in the dark. Here's a bonus tip for listeners intrigued by this tech. If you're dabbling in AI projects that rely on optical sensing, consider exploring organic semiconductor interfaces. They might be your gateway to ultra efficient photonic devices that don't need complex cooling or huge power supplies. Now, I'm curious, how do you think these advances in near infrared sensing might reshape the AI devices you rely on daily? Drop your thoughts and questions in the comments on my Medium page or Twitter. I love hearing your perspectives. Before we wrap up, remember this gem from Niels Bohr that always inspires me when delving into the quantum and photonic frontier. Prediction is very difficult, especially if it's about the future. But if OLEDWorks and their partners have anything to say, the future of NIR detection looks brighter and smarter than ever. Stay tuned for more insights right here on AI with Shaily. Follow me on YouTube, Twitter, LinkedIn, and Medium for deep dives and fresh AI news. Don't forget to subscribe and share your point of view, because AI is not just about machines, it's about us too. Thanks for listening, and I'll catch you next time where we'll keep exploring the AI innovations shaping our world.